Assalamualaikum. Today we are going to learn about the exponential functions, which are very closely related to the indices, or the singular is the index. So you have learned about the index before, alright? So why we call it as an index? We have something like x to the power of 2. So this is called as the base, alright? And this is as the index. Index is the power of this variable x, right? And we have 8 law of indices that you have to know, right, before we proceed with solving, simplifying the index and the solving index equation, right? So you know, when we call an exponent, so we have the base e, so e to the power of x. So this is an exponential function, right? So it is very closely related to the index. So if we have x to the power of m multiply with x to the power of n, therefore the index will plus, all right, x to the power of m plus with n, all right. And if we have x to the power of m divided with x to the power of n, therefore we'll have x, when we want to combine the index, it will become minus, so m minus n. And if we have x to the power of m multiply, in the bracket and outside the bracket we have n, right? So we can actually multiply that m with n, all right? So we have x to the power of m multiply with n, we have x mn, right? So x to the power of mn, right? For the fourth rule, if we have xy in the bracket and outside the bracket we have the power of m, therefore this power can goes to the x, can also go to the y, therefore we have x to the power of m, y to the power of m. If we have x to the power of 0, therefore we have 1. 100 to the power of 0, it will become 1. 1000 to the power of 0, it will become 1. So anything to the power of 0, it will become 1. But if 1 to the power of anything, it will become 1. 1 to the power of 2, 1 to the power of 2 is 1. 1 to the power of 100 is 1, right? So 1 to the power of any number, it will become 1. If we have x to the power of negative m, therefore this is actually equal to 1 over x to the power of m, right? 1 over x to the power of m. To remove that negative part, right? So this is actually also equal to 1 over x to the power of m, all right? Because 1 to the power of m is 1 and x to the power of m. So because this power will go this and will go to this, all right? Something like this, right? If we have, all right, if we have, all right, another one from this, all right, and as an extension for this part, before I forget, we have x over y to the power of m, therefore we'll have x to the power of m over y to the power of m, because this power will go to x, will also go to y. Right, for the last one, if we have x to the power of m over n, so we can write this, all right, x to the power of the m is at the upper part, so we have to write m at the upper part, and n here, so n is below here, so we have n here, all right. We can also write this as x to the power of m is to the power of x, all right. So have something like this, all right. So this is actually the same. Right, if you can forget, so you just recall the x to the power of m of n. Which one is the one at the top? So of course this one. So we'll have x square root. So at the top here m, at below here with n. Right, that's basically how you remember. Right, so we have known this law of indices. Now we want to use these properties of index. All right, so to simplify the expression, index expression. Suppose we have this, all right. So we can actually, all right, so we know that this power of 2 will go to 3, will go to 4, will go to y, all right, we go to z, all right, something like this. So we can actually simplify this as x to the power of negative 4, y z to the power of 2 multiplied with, right, now we have 3 to the power of 2, y to the power of 4 multiplied with 2, we get 8, z to the, that one is x, y to the power of 2 multiplied with 2, we get 4, z to the power of 1 multiplied with 2, we get z2, divided y by 3, x to the power of 3, y, z to the power of 4. Now we need to collect those the same terms, all right, of the same variable here. If we have like, right, 3 squared with 3, so of course we will have 3, right, because it is divided by, so we have the index will become minus, so 2 minus 1. Now I'm going to write x, so we look at x here, we have x here, look at x, x multiply x divided by x. So when we have a multiply, we have a negative 4 plus with 8, but when we divide, it will become minus 3. All right, for y now, you consider y here. So we'll have y 1 plus 4 minus 1. All right. Now we have z squared. So we have z to the power of 2 plus with 2. You divide with minus 4, right? Something like this. And then we need to simplify this. 3 to the power of 2 minus 1 will become 3. X to the power of negative 4 minus 3. Therefore, we'll have x to the power of 1. All right, and this one will become x to the power of 1. We don't write, so that one will be remain as x. Y to the power of 4 and z to the power of 0. Yeah, all right, because 2 plus 2 is 4, 4 minus 4 is 0. What will happen to z to the power of 0? We know that anything to the power of 0 will become 1. Therefore, 3xy to the power of 4 multiplied with 1. This is actually equal to 3xy to the power of 4. All right, now let's go to example number 2. Suppose we need to simplify this one. All right, so let's just expand. We know that when we have the power like this, we can multiply inside, right, with this power. Okay, something like this. So we will have x to the power of negative 3 multiplied with negative 2 will get a positive 6. And then we'll multiply with x to the power of 8 multiplied with a negative 1 over 4, we'll have a negative 2. Divided by x to the power of a negative 3 over 2 multiplied with the x to the power of negative 15 over 2. All right. So if you want to combine the one at the numerator together with the one at the numerator, and the one at the denominator with the one at the denominator, also can. Right, so you have something like x to the power of 6. Right, multiply will become plus with a negative 2. And now at the denominator, I will have x to the power of negative 3 over 2 plus with a negative 15 over 2. All right, now we want to simplify this. All right, I'll put in here. So suppose I have x to the power of that one, 6 minus 2 will become 4. And at the denominator will become, that one is actually a negative 3, right? So we'll have a negative 18, right? So we have a negative 18. So negative 3 minus 15, so we have negative 18 over 2, so an x to the power of negative 9. Right, now we need to simplify this one. So we have to bring x to the power of, all right, if you don't want to bring x to the power of 9 to the numerator, also okay. So you can just divide, right, x to the power of 4 right now, because we need to consider the index of 4 minus negative 9, because it is a division. So minus a negative 9. So this will become x to the power of 4 plus with 9. So this is x to the power of 13. So we are done with this one, right? X to the power of 13 is the answer. Right, let's try to simplify this one. All right, suppose we have this. We have this. All right, so let's just look at the numerator. We will see denominator here will have 2 to the power of 2n, right? Because 2 and n can be multiplied. Therefore, we want to remain 2 to the power of 2n together, right? So let's just break this up, all right? So we have something like 2 multiplied with 2 to the power of 2n, right? If you have plus 3, means that 2 to the power of 3. Because when we consider this and this, it will become plus, right? That's something like this. Right now, that one is 2 to the power of 3, right? We have a minus 24, right? So we have that one as 2 to the power of 2n minus 2, right? 2 to the power of 2n minus 2. I expand this one first. I expand this one to have this, all right? Now at the numerator, at the denominator, I'll have 10. That one will become actually, all right, this is actually multiplied with 2 to the power of 2n. Now, bear in mind that I want to remain 2 to the power of 2n, all right? I want to keep it because we can actually cancel later. All right, so that's the strategy, all right? So, you know, when you have 2 to the power of 1, this one is actually 2 to the power of 1. You want to combine with 2 to the power of 3. So what we will have, so we have 2 to the power of 1 plus with 3. So this one will become 2 to the power of 2n. Right, for this part, we have 24, right? Multiply with 2 to the power of 2n. That one minus means that we have 2 to the power of negative 2. All right, 2 to the power of negative 2. Right, we have 10, 2 to the power of 2n. Right, now we want to simplify this again. We have 2 to the power of 4. So 2 to the power of 4 is actually 16. 16 2 to the power of n minus with, alright, so we want to combine this part here, 24 with 2 to the power of negative 2. So we have 2 to the power of negative 2 is actually 1 over 2 to the power of 2. Alright, because we have 2 to the power of negative 2, this is actually 1 over 2 to the power of 2. So we have something like this. Alright, now that one will multiply with 2 to the power of 2n. This one will divide with 10, multiply with 2 to the power of 2n. Now, we have, alright, I continue here. Alright, now we have this as 16, 2 to the power of 2n minus, alright, 24 will divide with 4. 24 divide with 4 will get 6. Alright, 6 2 to the power of 2n. Alright, so we'll have over 10 2 to the power of 2n. Right. If you want to factorize 2 to the power of 2n, also okay in this case. But actually, you have 16 minus 6. So you have 10 over 10 multiplied with 2 to the power of 2n over 10 to the power of 2 to the power of 2n. Alright, maybe you are wondering, how do I get 10 at the numerator? I know. Some of you will be wondering, how do I get 10 here? Right, you can just imagine, suppose you have 16x minus 6x. What will you get? Of course, 10x. If you have 16 donut minus 6 donut, of course you'll have 10 donut. If you have 16, 16 multiply with the n minus 6 multiplied with n, of course you have a 10n. In this case, we have now 16 2 to the power of 2n minus 6 2 to the power of 2n. You just assume that 2 to the power of 2n as a variable. Alright, so of course you'll have 10 2 to the power of 2n. That's basically how do I get. So now we can cancel, this one will become 1, this one will become 1. So of course the answer is 1. Alright, now, right, we are done with simplifying index. So you have to do a lot of exercises to solve this kind of problem. Now we are going to proceed with the index equation, the equation which involves the index. Suppose we have this kind of equation. So what should we do? We should have the same base actually. In this case, with the base 5, because we have 5, right, to x minus 1. 25 is actually 5, no, sorry. That one will multiply with 5 to the power of 2. That is 25, you have x. Alright. 125, 5 to the power of 3. Bear in mind that if we have the same base, when we multiply, the index will become plus. So we have 5 to the power of 2x minus 1 plus with 2x. I guess there is problem with this question. Let's just put 3x here. Oh, sorry, yes, no problem, sorry, no problem. Right, so we have this one. Right, this is actually the part where we have on the right side 5 to the power of 3. Because now we have one index on the left side and one index on the right side, and both index have the same base. Of course, now we can actually compare the index. So we have that 2x minus 1 plus with 2x is equal to 3. Simplifying this will give us 4x minus 1, which is equal to 3. 4x, which is equal to 3 plus 1 will be 4. X is equal to 4 divided by 4, we get 1. 1 is the answer for this one. Alright? So that's basically the index equation. You can find the value of x. When the equation asks you to solve, means that you have to find the value for x. And now, let's proceed with finding this solution. Alright, so what is the base? Of course, base 2 in this case. So we have 2x minus 4. 16, how to change to base 2 will become 2 to the power of 4. But outside, it will have 2 minus x. Please put it in bracket. Now, we have 2 to the power of, right, x minus 4. This one will become 2 to the power of, I want to expand that one, will become 8 minus 4x. Now, because we have the same base now, we can compare the index. So I compare x minus 4 with the 8 minus 4x. Now, I want to solve this linear equation, right? So I want to bring negative 4x on the left side and negative 4 to the right side. So we'll have x plus with 4x. This one will become 8 plus with 4. So I have 5x, which is equal to 12. Therefore, I have x, which is equal to 12 over 5. Right? We are done with this one. Now, Let's see this example. We need to solve this. You can use, kind of base 2, because 8 is actually 2 to the power of 3. So we have 2 to the power of 3, but outside 3 we'll have 1 minus 2x. Please put in a bracket. You multiply with 2 to the power of 2x. 128 is actually, I guess, 2 to the power of 7, right? 2 to the power of 7. Yes, 2 to the power of 7. Right now I want to combine the one on the left side because we have the same base here. Of course, we can combine the index. So we have something like 2 to the power of, alright, now I have 3 minus 6x. I expanded one because it is multiplied, so we'll have plus with 2x. What about the one on the right side? So we can, because we want to compare, we cannot compare something like this. Alright, we cannot compare something like this. Oh, x equal to 1. That is wrong. You have to have the base which is of the same level. Now you can compare, right? So in this case, you have to bring this to the numerator. How? So it will become 2 to the power of a negative 7. It will change. All right. So now you have one index on the left side, one index on the right side. You can compare the index because they have the same base. Right. So we have 3 minus 4x. So you solve this one. This one is equal to negative 7. And negative 4x, which is equal to negative 7 minus root, will become a negative 10. Therefore, x will become a 10 over 4. Alright, so this will become a 5 over 2. That is the answer for this one. Right now, we have this example. We want to solve for the value of x. So, we have to have some strategy in this case. Right. Actually, we can have 3 to the power of x as a variable. Alright, so let's try 3 to the power of x plus with 2 multiply with that one is actually 3 to the power of x multiplied with 3, because 3 to the power of 1. Alright, so x plus 1. Alright, this can be break out into this part. Alright, now we have plus with 3 to the power of x. Alright, multiply with that one is actually 3 to the power of 2. This is actually equal to 144. Right now, I have 3 to the power of x plus with what we call that one. It will become, right now I want to multiply 3 with 2. All right, so I have 6. All right, I multiply with 3 to the power of x. This one, right, I want to write this case. All right, so I will want to write 3 squared. Therefore, I will have 9. You multiply with the 3 to the power of x. So this one will become 144. You just assume that this is a variable. Alright, if you are confused, so now you need to use this. You let, suppose we have variable m, which is equal to 3 to the power of x. So you have to change all the 3 to the power of x into m. So you have something like, alright, I have m plus with 6m plus with 9m. This is actually equal to 144. Right, combining this, of course, you get 16m. This is equal to 144. So you have m, which is equal to 144 divided by 16, right? So you have 16 divided by 16. So m, which is equal to 9. But what is m? M is actually 3 to the power of x. Therefore, 3 to the power of x equal to 9. Why? Because we have m equal to 9, because m is actually 3 to the power of x. Right, now we have to solve this index equation. So 3 to the power of x, how to solve this one? We have to make 9 as base 3. So 3 to the power of x equal to 9 in base 3, we get 3 to the power of 2. Because now we have the same base on the left and the right side, we can compare the index. We have x, which is equal to 2. We are done, right? Simple. Right, now let's go to example number 8 here. Suppose we have this, right? So, all right. This looks similar to the previous one, but this one is actually a quadratic. How do I know that this is a quadratic? Because we have 3 to the power of 2x, this one 3 to the power of x. So that's the hint here. So we have to remain this as 3 to the power of x. All right, I just write 2 outside. I minus 4, that one I'll have 3 to the power of x, plus with 3, this one equal to 0. Alright, maybe you don't see yet, alright, but you just need to let m equal to 3 to the power of x. Therefore, in this case, this part, 3 to the power of x, will become m. So now we have m squared minus 4m plus with 3 equal to 0. Now you know that this is actually a quadratic equation. So when you want to solve the quadratic equation, you have three methods. The first one, you can use factorization, you can use the completing the square, or you can use the formula. Suppose you want to use the what do we call the factorization method. Therefore in this case I have m minus 1, m minus 3, right, which is equal to 0. So I have m minus 1 which is equal to 0, or m minus 3 which is equal to 0. In this case m is equal to 1, and another one m which is equal to 3. But what is m? M is actually 3x. Therefore I have a 3x which is equal to 1, or a 3x which is equal to 3. Alright, I'm just substituting this variable m with 3 to the power of x. But now, right, in this case you have to solve for the variable x. Alright, so 3 to the power of x, how do I make 1 as the base 3? So 3 to the power of what number will become 1? Of course 3 to the power of 0. For this case, 3 to the power of x, of course this one is 3 to the power of 1. So in this case we can compare the index. We have x which is equal to 0, or x which is equal to 1. Alright, now that is one way of checking your answer. You can actually try to substitute x equal to 0 inside this equation, and then you try to solve and you get 0. Or you can try to substitute with x equal to 1 inside this equation. Alright, now let's go to example 9. Suppose we have example 9 here. We need to solve this one. Alright, so almost similar to the previous one. Alright, it's just that you have to modify a little bit, because I have a 3 to the power of 2x and 3 to the power of x. That's the hint that you have to use the quadratic equation. So you have, in this case, 3 to the power of 2x multiplied with 3 plus with 26. That one remains as 3 to the power of x. I bring 9 to the left side. I have minus 9 which is equal to 0. So in this case I have 3, right, 3 to the power of x to the power of 2. I bring 2 outside here. I just modify this part, it will become this. Right now it will become that one, it will become plus 26, 3 to the power of x minus 9 which is equal to 0. Right now we can let m which is equal to 3 to the power of x. Therefore we have 3m squared plus with 26m, you minus 9, this is equal to 0. Right now you see that this is actually a quadratic equation. So when solving quadratic equation, you have many methods. So you just use any easy method that you see. Alright. So in this case, maybe I use the factorization. I have a 3m minus 1. Another one will be m plus with 9. Alright. Therefore, the answer will become 3m minus 1 which is equal to 0. Another one, of course, m plus 9 will become 0. So in this case, m which is equal to 1 over 3. Another one, m which is equal to a negative 9. Right? Now, what is m? M is actually this one, 3 to the power of x. You have to rewrite that m as 3 to the power of x. So I have 3 to the power of x which is equal to 1 over 3. Another one, 3 to the power of x which is equal to negative 9. Alright. Now, okay, what will happen? In this case, right, 3 to the power of x, this one will become a 3 to the power of negative 1. Therefore, x which is equal to negative 1. What about this one? We have 3 to the power of x. Alright, this one will become negative 3 to the power of 2. But can we say that x is actually a negative 2? No, that is wrong. Therefore, for this case, because we don't have a negative on the right side, on the left side of this equation, but we have a negative on the right side, so this negative is a problem now. Therefore, actually, we cannot solve this one. No solution for this one. In this case, we just have only one answer, which is x which is equal to a negative 1. Alright? Now, let's get to example number 10 here. We need to solve for the variable x. Alright, so we have to modify a little bit. and maybe we can put the base as base 2. The simplest base should be base 2 in this case. So we try to modify. All right, so we have 2x to the power of 2 multiply with 8 will become 2 to the power of 3, but outside 8 will have 2x. You divide with 2 to the power of 3, you have x outside, and 16 is actually 2 to the power of 4. Right, now you want to simplify this one. I'll have if you want to multiply it to the right side also okay. All right, so you have 2 to the power of x squared, all right, multiply with 2 to the power of 6x. This one will become 2 to the power of 4 multiply with 2 to the power of 3x. Some of you may see, all right, so I know this is multiply this one multiply this one. That is wrong. When you have a base, an index, all right, with the same base, when you multiply, you have to add the index. So you just need to consider this part, right? All right. So we have 2, that one is actually 6x, right? X squared plus with 6x, and now on the right side I'll have 2, 4 plus 3x. The common mistake that students do, they see, all right, 4, 3x will become 12x. That is wrong, all right? Because this should be a plus here, an addition. Now we can compare the index because we have the same base on the right and the left side. Therefore, we have x squared plus with 6x equal to 4 plus with 3x. This is actually a quadratic equation. So x squared plus with 6x minus 3x minus 4, this is equal to 0. We have x squared plus with 3x minus 4, this is actually equal to 0. We have to solve the quadratic equation, very easy, right? So we just need to use the factorization. I'll have an x plus with 4, x minus with 1. This one equal to 0, yeah? Positive 4x minus 1x as positive 3x, right? So you'll have x plus with 4, which is equal to 0, another one x minus 1, which is equal to 0. Therefore, I'll have x, which is equal to negative 4, another one x, which is equal to 1. So we are done with this one. Right now, what about this one? Right, this is a little bit challenging. Right, we have this equation. Right, so actually, we want to write, right? You can actually break out into these, right? Let me just write x to the power of 1 over 3 to the power of 2 outside. All right, this is the part where I break these out, this into this one. Right now, this one minus 5, I put in the bracket x to the power of 1 over 3 minus 3 equal to 0. You see that this can be a quadratic equation because this one is to the power of 2, but this one don't have the power of 2. So we have to let m, which is equal to x to the power of 1 over 3. You can use any variable actually, m and k, all right, but don't use x. All right, so we have 2m squared minus with 5m minus with 3. This one will become 0. What type of equation is this? It's a quadratic equation, so you can solve using a factorization method. In this case, when you use the factorization method, you have m minus 3. Another one will be 2m plus with 1. This one will become 0, right? Okay, now we need to solve this one. So I have m minus 3, which is equal to 0. Another one, 2m plus 1 will become 0. So in this case, m, which is equal to 3. Another one will be m, which is equal to a negative half. All right, now we know that x to the power of 3 is actually m, so we have to rewrite this as x to the power of 1 over 3, which is actually 3. Another one, x to the power of 1 over 3, which is actually a negative 1 over 2. All right, so to remove the power of 1 over 3, you have to take cube. All right, so you have to multiply, you have to take to the power of 3 on both on the right side. So I have x, which is equal to 3 to the power of 3. Why? Because to remove the x to the power of 3, I have to take to the power of 3 on the left side, to the power of 3 on the right side. Right, so this one will become x to the power of 1. This one will become x, which is actually equal to, I guess, 27. All right, for this case, right, so we have to take x to the power of 3 on the right side. I'll have a negative 1 over 2 to the power of 3. So taking that to the power of 3 will remain as a negative 1 over 2 to the power of 3 is actually 8. All right, so we have two answers here. Okay, so we are done with this one. Now suppose we have this type of equation. All right, so how to solve it? Right, so we should see the same thing as this one as 2 to the power of x, this one x, so that is actually a quadratic equation, but you have to modify a little bit so that it is clear for you. So you have e to the power of x to the power of 2 minus 2 e to the power of x minus 3, which is equal to 0. We want to change this e to the power of x as a variable m. Suppose we have to let m, which is equal to e to the power of x. Therefore, we have m to the power of 2 minus 2m minus 3, which is equal to 0. Using the factorization method, therefore, we have m minus with 3m plus with 1. All right, we have a negative 3m plus m. All right, negative 2m. All right. Now we have m, which is minus 3, which is equal to 0. Another one m plus 1, which is equal to 0. Therefore, we have m, which is equal to 3. Another one m, which is equal to a negative 1. So we know that m is actually e to the power of x. So we have e to the power of x, which is equal to 3. Another one e to the power of x, which is equal to a negative 1. How to remove the, what do we call, e to the power of x? In this case, you have to take the natural log. Right? This is something new for you. You have ln in your calculator. Right? Try to find ln. It is actually besides on the right side of the log. Right, you find log on your calculator, you have ln on the right side. You have to take ln, right? Ln e to the power of x, which is equal to ln 3. Why? Because I put ln on both sides of the equation, right? So I have this ln. In this case, I also have ln e to the power of x, ln negative 1. But ln of negative 1 is actually undefined, because when you press a ln of a negative number is not defined. It will be error. Right, this one will have no solution, right? But this one will have, right? When you have ln e, therefore you have x. You will learn further in the next chapter, which is a logarithmic, and then you understand, right? Why ln e to the power of x will become x, because we have ln is actually a log base e to the power of x. So when you have log of base e to the power of x adds to bring 1, so you have x log base e. When you have log base the same as this, you know, then you will get 1. So this is actually x multiplied with 1. So in this case, you have x. Right. For the time being, you just take note of this. So you have ln 3. Pressing your calculator, all right, you get a ln 3, which is given by, right, I have ln 3. The value is actually 1.0986. So that's the answer. All right, what about this one? All right, this is the last example here. Now we have 2 and 3. Can we change the 3 in the base 2? Cannot. Can we change 2 into the base 3? We cannot. Therefore, what we should do is actually we have to solve this by taking log on both sides. So we have log of 2x minus 2 to the power of 2x minus 1 is equal to log of 3 to the power of x minus 1. And then we will have to use the law of logarithm and to solve the variable x. So we will learn this in the next, right? In the next video, right? Next video. So don't miss to watch the next video. For the time being, thank you for watching this video.